Hello students. In this question we have to evaluate the integral of x sin x cos x upon sin to the power 4x plus cos to the power 4x dx from 0 to pi by 2. Let's call this as I first of all. And equation number 1. So we know that when we talk about integration of fx dx from 0 to a, we can replace x by a plus 0 minus x. So this is equal to f of a minus x dx. Applying the same property here also, we'll get I pi by 2 minus x, because for us a is pi by 2, sine of pi by 2 minus x, cos of pi by 2 minus x divided by sine to the power 4 pi by 2 minus x plus cos to the power 4 pi by 2 minus x. Also the limits will stay as the same dx. So this gives us integration of 0 to pi by 2 minus x. Sin pi by 2 minus x is cos x. Cos pi by 2 minus x is sin x. Cos to the power 4x plus sin to the power 4x. So if we observe the first equation and the second equation, they are exactly same, just the difference of x and pi by 2 minus x here. So as we have to get rid of the x, let's add these equations. We will get 2i integration of 0 to pi by 2. Here it was x sin x cos x upon sin to the power 4x plus cos to the power 4x dx plus pi by 2 minus x with the rest of the terms same. Sin x cos x upon sin to the power 4x plus cos to the power 4x dx. So we see that this term and this term gets cancelled. We are left with 2i is equals to 0 to pi by 2 times sin x cos x upon sin to the power 4x plus cos to the power 4x dx. So I will be equal to pi by 2 we take out common and 2 from the left side from here, integration of sin x cos x upon sin to the power 4x plus cos to the power 4x dx. So we can divide in numerator and denominator by cos to the power 4x. We would get pi 8 by 4, 0 to pi by 2 sin x cos x by cos 4x upon sin to the power 4 upon cos to the power 4 plus 1 dx. So this is going to give us pi by 4, 0 to pi by 2, we'll have tan and sec. So tan x into sec square x upon tan to the power 4x plus 1 dx. So since we see that we have a lot of things in tan now, let tan square x is equals to c. So 2 tan x sec square x dx will be equal to dz. So we see the limits also. So when x was equal to 0, tan square x will be equal to 0 and hence z will be 0. X is equals to pi by 2. So z will be equal to tan square pi by 2, which is infinity square or infinity. So now we have our new integration. I is equals to pi by 4 as it is. Limits will be now from 0 to infinity. Tan x sec square x by tan to the power 4x plus 1. So dz by 2 upon z square plus 1. This can also be written as pi by 8 times 0 to infinity dz upon z square plus 1, which is on integration gives us tan inverse of z. So tan inverse z and limits are from 0 to infinity. Putting the limits, pi by 8 times tan inverse infinity minus tan inverse 0. So this gives us pi by 8 times pi by 2 minus 0, which is pi square by 16. So this will be the solution to our